What if the most terrifying fall in the universe wasn't down, but forever? Imagine crossing a boundary where time breaks, space folds in on itself, and escape becomes impossible. Not because you're trapped, but because the universe itself won't let you leave. Here's the part that sounds impossible. If you fell into a black hole, the entire universe could age billions of years, while for you, everything slows down. You wouldn't see your end coming. You wouldn't even realize when it begins. No one knows exactly what happens inside a black hole. But today, we're going to follow the journey physics predicts, step by step, from the moment you fall to the point where reality itself stops making sense. So first, let's answer the most basic question. What is a black hole? A black hole forms when a massive star exhausts its nuclear fuel and collapses under its own immense gravity. The star's core implodes, shrinking into an infinitely dense point called a singularity. Around this point, gravity becomes so strong that not even light can escape. The edge of this no-return zone is called the event horizon. Cross it, and you are trapped forever. No force in the universe can pull you back. This is where physics reaches its limits, where our understanding of space, time, and matter is stretched to the extreme. Black holes exist in many sizes. Some are stellar black holes, formed from single stars, only a few kilometers across. Others, called supermassive black holes, sit at the centers of galaxies and contain billions of times the mass of our Sun. The Milky Way itself has one such monster, Sagittarius A star, quietly lurking 26,000 light-years away. Fortunately, it's far enough that we are safe, but for anything that drifts too close, the rules of the universe become terrifyingly clear. Who can fall into a black hole? In theory, anyone or anything. Humans, stars, planets, spacecraft, even light itself. Gravity is impartial. It does not care about size, mass, or composition. Once you approach a black hole, all matter obeys the same cosmic law. It is pulled inward inexorably. As you near the black hole, the first warning is subtle but deadly. Gravity will begin pulling harder on the parts of your body closer to it than the parts farther away. If you fall feet first, your feet experience a stronger pull than your head. This stretching effect, scientifically called spaghettification, will elongate your body like taffy. Molecule by molecule, you will be stretched vertically and compressed horizontally, a process that is horrifyingly violent in small black holes, but may be surprisingly gentle in supermassive ones, at least at first. For large black holes, you might cross the event horizon without noticing anything unusual, only realizing the danger once escape is impossible. Time itself begins to behave in ways that defy intuition. To a distant observer watching you fall, your movements appear to slow. You seem to freeze at the edge of the event horizon, your image stretching, fading, and eventually disappearing into darkness. From the observer's perspective, it would appear as if you never truly crossed the boundary. Yet, from your own perspective, time flows normally. The universe outside accelerates in a breathtaking blur. Stars burn, galaxies shift, entire cosmic cycles play out in moments. Both perspectives are real. Both are true. This is one of the strangest, most counterintuitive predictions of Einstein's theory of general relativity. Crossing the event horizon marks the point of no return. Inside, space and time swap roles in ways that challenge comprehension. Every direction leads inward toward the singularity. The concept of out no longer exists. The singularity itself is a point of infinite density, where gravity crushes everything to an infinitesimal scale. Our current laws of physics break down. What happens at this core is unknown. Our equations cannot describe it. Information may be destroyed, preserved in ways we do not yet understand, or transformed into something beyond imagination. Physicists continue to debate this, but one thing is certain: nothing from inside can communicate back. What would you experience physically? Beyond spaghettification, your body would undergo forces far beyond anything survivable. Atoms would be torn apart, molecules stretched and scattered. Light would bend, time would warp, and reality itself would twist into shapes impossible for the human mind to grasp. Black holes are not just cosmic vacuums, they are testing grounds for the ultimate limits of matter, energy, and life. But there is more to black holes than destruction. They are central to the evolution of galaxies, the birth of stars, and the shaping of cosmic history. Supermassive black holes influence entire solar systems, while smaller ones may seed the creation of new stars from the debris they consume. In a way, these objects are both destroyers and creators, holding the universe in a delicate balance between chaos and order. Sometimes, theoretical physicists explore a more hopeful or strange scenario. Could a black hole be a gateway to another universe? Could it be a cosmic tunnel or a wormhole? These ideas remain speculative, but they highlight how little we truly understand. Every black hole challenges our most fundamental assumptions about reality, physics, and the fate of matter. So what happens if you fall in? You wouldn't just disappear, you would witness time dilate, space distort, and the universe unfold at unimaginable speeds. You would experience a journey that no human has survived or can survive. Your fall would take you through extremes of gravity, space-time, and energy, ultimately ending at a singularity where the known rules of existence collapse entirely. Black holes remind us of our fragility, but also of the incredible complexity and beauty of the universe. They are a gateway to questions about time, reality, and existence itself. And the most unsettling part? They're out there, all around us, shaping galaxies silently, endlessly, and invisibly. Next time you gaze at the night sky, remember, somewhere a region of absolute darkness bends reality, pulls on matter, and warps time itself. And if you ever fell into one, the universe would never be the same for you again.